Hi students, in this video you will see how to create an equation using the variables given in the figure, and you will see how to solve the equation to find the sides for the right angle triangle. The most important thing to remember is that when you see a right angle triangle, they are going to link the sides here. So you have to have an equation, and it begins with the Pythagoras theorem. As you know, the hypotenuse, which is the longest side of the right angle triangle, is always opposite to the 90 degree. So if you take the length of the hypotenuse as C, keeping the other two sides as A and B, so the longest side C squared is going to be equal to A square plus B square. So this is the theorem that's going to help you create an equation using the given data in the figure. Let me mark the sides here. This is my 90 degrees, so opposite to my 90 degree is my longest side, and I'm marking it as C. And this is going to be my A and B. There is no harm in interchanging this as taking this side as B and this as A, no problem. So as we mentioned, C square is equal to A square plus B square. From the figure, my C is x plus 1. So I'll write here x plus 1 the whole square is equal to my A is 6. So 6 squared plus, I have my B here, which is x minus 1. So it's going to be x minus 1 the whole square. Now let's see how to expand and rearrange this equation and solve for x. When you have x plus 1 the whole square, you can apply the identity, which is a plus b the whole square is equal to a square plus 2ab plus b square. Now for students who cannot memorize this, you can always do the expansion of x plus 1 times x plus 1, which is the same meaning as x plus 1 the whole square. So when you can do the term by term multiplication, and you can expand it, and your answer will be equal to x squared plus 2x plus 1. So either you can use the identity and find it straight away, or you can just expand the brackets and get your expanded form for this expression. So let me write x squared plus 2x plus 1 is equal to 6 squared is 36, plus again here I have x minus 1 the whole square. To remind you of the identity, when it is a minus b the whole square, the identity is a square minus 2ab plus b square. It's just the sign which changes. If it's plus, it's a plus 2ab term in the middle. And if it's minus b, so minus, it's going to be a minus 2ab. The remaining terms just remain the same. If you think you're forgetting this identity, just don't panic. Multiply the brackets here for x minus 1 times x minus 1. So you do the term by term expansion. And again, you'll get the same answer as the one that you get while applying this identity. So it's going to be x squared minus 2x plus 1. I'll write the answer here for this. X minus 1 the whole square is x squared minus 2x plus 1. Now you can prefer to bring all the terms to one side and then simplify, or you can see when you have same terms with the same sign on either side of the equation, so you can just cancel them, because obviously when this x squared term goes to the other side, it becomes negative. So x squared minus x squared is going to give you a 0. So you can just straight away cancel it, making your calculations faster and easier. I can also see a plus 1 on either sides of the equation, so I'm just cancelling them too. So what is remaining is 2x is equal to 36 minus 2x. Now I'll bring all the x terms to one side and keep the constant here. So I have 2x plus 2x is equal to 36, where it becomes 4x equals 36, and I can say my x is going to be 36 divided by 4, giving me 9. So my solution is x equals 9. Just talking about an extension, they may ask you to find the length of the sides of the triangle. In this case, this side is going to be, your x is 9, so 9 minus 1 giving you 8 centimeter or 8 units. And here it's going to be 9 plus 1, which is 10 centimeter or 10 units. Another question to expect here is to find the area of this triangle. So we know the formula for area of a triangle is equal to half times base times height. So now we have found the value for the base and height, which is 8 being the base and 6 being the height. So you have to just substitute it. So it becomes half times 8 times 6, which is equal to 24 centimeters square. Now let's discuss another question here. In triangle ABC, the line BD is perpendicular to AC, and AD is x plus 6 centimeter and DC is x plus 2 centimeter. The height BD is given as x plus 1 centimeter. The area of the triangle is 40 centimeters square. Show that x squared plus 5x minus 36 equals 0. Now looking into this triangle, though we have a right angle triangle, we don't have all the three sides given. We don't know what the hypotenuse is. So we will not apply the Pythagoras theorem here because we just know the base and the height. So the relation that we can take is connecting the base and height with the area of the triangle. The area of triangle ABC, which is the entire shaded region. So we start with making the equation where the area of the triangle is half times base times height. Now the area here is 40 equal to 1 over 2 times the base. Now this is my base, which is AC, and you have the measurements given in terms of x here. So I know my AC is nothing but AD plus DC. So in terms of x, AD is x plus 6 plus my DC is x plus 2, which gives me x and x. It's going to be 2x and plus 8. 6 plus 2 is 8. I'm going to add the terms and not multiply. Please don't make any error here. So my base AC is 2x plus 8 times my height here. This is the perpendicular height, BD, which is x plus 1. Now I have an equation here. So let me simplify this and try to make it in this form. Cross multiplying, I have 80 is equal to 2x squared plus 2x plus 8x plus 8. So this is going to be equal to, I'm just shifting this 80 to the other side, so I have 2x squared plus 10x plus 8 minus 80 equals 0. So I have just shifted this 80 to the other side, that's why it has taken the form of minus 80 here. And this equation is 2x squared plus 10x minus 72 equals 0. They have asked me to show that the equation is x squared plus 5x minus 36 equals 0. You can see that it's x squared here, it's 2x squared, it's 5x, it's 10x here, and negative 36 is negative 72. So this is just doubled, and what I can do is divide the whole equation by 2. So when I divide the whole equation by 2, what I get is x squared plus 5x minus 36 equals 0. So this is exactly what they want. Let's answer the second question. Solve the equation x squared plus 5x minus 36 equals 0. Now x squared plus 5x minus 36 equals 0. My sum here is 5 and my product is negative 36. So the two numbers that can give me a product of negative 36 and a sum of plus 5 will be plus 9 and minus 4. So I'm using the sum and product method here. So this equation becomes x plus 9 times x minus 4 is equal to 0, which means x is going to be negative 9 or x is going to be positive 4. And since we are dealing with length, our desirable solution is x equals 4 and not x equals negative 9. Now using these values, you can see when we take x equals negative 9, see negative 9 plus 1 can give you negative 8, which is not the acceptable answer because length cannot be negative here. Hence, taking the value of x equals 4, you can see that 4 plus 1, which is going to be 5 centimeter, and here you have 4 plus 2 giving you 6 centimeter. This is again 4 plus 6 giving you 10 centimeter. Answering the last part of the question, which is calculate the length of BC. Now BC can be considered as the hypotenuse of triangle BDC. You have here 6 centimeter and BD to be 5 centimeter. Applying Pythagoras theorem here, c square is equal to 5 square plus 6 square, which gives you c square is equal to 25 plus 36. You get c square equals 61. So c is going to be square root of 61. In a calculator paper, you can find the square root of 61 to be 7.81 centimeters to 3 SF. So that's the answer for the length of BC. So length of BC is equal to 7.81 centimeters.